So much like before, where we had this analogy of an office building with different offices and different floors and trying to move from one location to another, that was converting units. In acids and bases, we're going to do the very same thing. Often, we're going to already know how many moles of a certain thing we have. Like, for example, hydrogen. We can know with pretty good accuracy how many moles of hydrogen are inside a certain solution. But we don't know what the pH of that solution is. So in order to find it, it's going to involve some dimensional analysis. Hopefully that's not too intimidating by now, but this is going to be how it works. We use the same metaphor as before. We're piggybacking on that idea of the office building. It's just that this time we're going into the basement. And there is only one elevator that goes into the basement of this office building, and that is in the moles office. So you need to get to moles of hydrogen or possibly moles of hydroxide, because those are the two key players for acids and bases. So if we start up here at moles, this is after you've already gone to moles of hydrogen if you're going toward the left, or moles of hydroxide if you're going toward the right. But either way, you have to start with moles. And then we're going to work our way toward finding either the pH or something very closely related called the pOH. But we'll work toward the pH first because that's the more common. You start with moles of hydrogen. And in order to go down this little map, we need to get to the concentration of hydrogen, which is simply moles divided by liters. And that will always give you concentration. In chemistry, we do the square 90-degree brackets around a certain thing, and that says we're dealing with the concentration of that substance, which is always moles of that thing divided by liters of solution. So to go down to the square brackets, simply divide by liters, and you're finished. Now, to go from concentration and get to pH, that's a little bit more complicated. This is where we involve the powers of 10 that I was talking about earlier. So we will need logarithms in order to go down, and we'll need 10 raised to the power of in order to go up. So if you have a concentration, which is almost always a very, very small number, then you'll take this tiny little decimal and you'll type in the negative log of that tiny little number. And when you do that, the result is the pH. And that should be between 0 and 7 if you're dealing with an acid, or it should be between 7 and 14 if you're dealing with a base. If it's anything outside of that region from 0 to 14, you probably did something wrong. Or the sample problem is not a good sample problem, but somehow somebody messed up. So if you already have the pH and you want to go back up toward moles, then we need to reverse every step along the way. So we need to undo taking the negative log. Well, from math class, we learned that that was called the anti-log. Or maybe you didn't call it that, but it's 10 raised to the power of, and then the negative sign here is simply to cancel out the negative sign here. 10 raised to the negative pH will take you up and land at the concentration of hydrogen. Now, in order to go from concentration up to moles, you'll simply multiply by liters, because that's the opposite of dividing by liters. And in this way, you can travel anywhere you want on the left side of this map. Now, if you already have the pH and you want to find something called the pOH, I'm not going to lecture so much on what that thing is, but I'm going to just tell you how to get the right answer on the homework and the test. So I hope that you're curious about what it is, and I hope that you're able to find that out. But for now, if you want the pOH, or any time that you're moving across this bridge, it's just 14 minus whatever you have. So if you have the pH, take 14 minus it, and you'll get the pOH. If you already have the pOH, 14 minus that thing equals the pH. So 14 minus what you have takes you across the bottom line of this map. And then as you go up the right-hand side, it is exactly the same as the left-hand side. On our way up from POH, you do 10 to the negative whatever that number was. And that will give you the concentration. From there, you can take the concentration times liters in order to go up toward moles of OH. Now remember, if you're on the right-hand side, then it will always be focusing on hydroxide. If you're on the left-hand side, it will always be focusing on pure hydrogen. Well, not hydrogen gas like H2, but hydrogen ions. So if you're going down, you divide by liters, up you multiply by liters. On this bridge, if you're going down, you take the negative log. If you're going up, you do the anti-log, which is 10 raised to the negative. And you always take whatever you're starting as the input for that particular mathematical idea. So you should be able to traverse anywhere around this circle, except you cannot bridge across that solid line. So if you have the moles of hydrogen starting right here, and you want to get to the moles of hydroxide, you cannot just go straight across. Unfortunately, you have to go all the way around to each individual office in order to get to the number of moles of hydroxide. But you just do the simple steps, and that will take you there. I think it's time for a sample.